All right, in our previous problem, we looked at solving a system of equations by using the graphing method. However, sometimes graphing is not always the most convenient method to use when you're solving a system. So for instance, in this particular problem, we're dealing with negative 266. Yeah, we're going to have to eventually divide it by 2 if we graph it, but we're still at 133. So in this particular problem, we're going to take a look at the substitution method. Okay, so in the substitution method, the first thing you want to do is you want to solve for one of the variables. Now you could pick any of the four. So I have an x, I have a y, a 4y, I have a 3x, and a negative 2y. I would pick the one that has a coefficient of 1. That will help you avoid fractions. Now, in some problems, you're not always able to avoid the fractions, but in this particular problem, if I look at the first x, I have a 1x. If I solve for that x, it allows me to get through the entire problem without seeing a fraction. So what I'm going to do is I'm going to start here with the x. I'm going to subtract 4y from both sides. And I'm going to isolate this x. So these 4y's cancel out, and I'm left with negative 4y minus 28. Okay, so I isolated the x, which is going to allow me to substitute this x in for the other x. So I'm going to bring everything down except for the circle. And where the circle is, I'm going to replace the circle with parentheses because I'm going to substitute a value in for x. In this case, my x is equal to negative 4y minus 28. So I'm going to substitute negative 4y minus 28 in for the x. Now what this does for me in my right-hand equation, I only have y's now. I don't have x's and y's. This will allow me to solve for the y variable. So first I'm going to distribute. So I get negative 12y minus 84 minus 2y is equal to negative 266. Then I'm going to combine like terms. I'm going to get negative 14y minus 84 is equal to negative 266. Then I'm going to add 84 to both sides of my equation, which gives me negative 14y is equal to negative 182. And then if I divide both sides by negative 14, y is then equal to 13. So this is useful because in my ordered pair, I know the y is going to be equal to 13. Now I just got to go back and solve for x. So what I can do is, since I know what y is, I can go back to my original equation where I isolated the x and plug a 13 in for y to solve. So x is equal to negative 4 times 13 minus 28. Then I just solve for x. So x is equal to negative 4 times 13 is negative 52 minus 28. Combine those like terms, negative 52 minus 28, and x is equal to negative 80. So my ordered pair is negative 80, positive 13. And if I wanted to, just like the graphing example, I could do a check step to make sure my answer is right. So I have x plus 4y is equal to negative 28. And I have 3x minus 2y is equal to negative 266. So I'm going to substitute the negative 80 in for x. I'm going to substitute the 13 in for y. So we have negative 80 plus 4 times 13 is equal to negative 28. I have negative 80 plus 52 is equal to negative 28, or negative 28 equals negative 28. So that checks out. Then the second one, I'm going to do the same exact thing. X is equal to negative 80. Y is equal to 13. 3 times negative 80 is negative 240. 2 times 13 is negative 26. And that's equal to negative 266, or negative 266 is equal to negative 266. So I know my ordered pair, negative 80, 13 is correct.